Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 10.1, 10.2, quadratic graphs and functions. Standard form of quadratic equation is ax squared plus bx plus c. The shape of a quadratic graph is going to be a U shape, either opening up or opening down. Again, if a is greater than 0, so if a is a positive number, then the graph will open up. If a is less than 0, the graph will open down. A parabola either has a highest point or a lowest point. Why not both? Well, if you look at the shape of the U, if it opens up, there's only a point at the bottom, right? It's not a big circle. It's not an oval. So it's only going to have a highest point or a lowest point. Because as it opens, let's call them the legs of the parabola open away from each other. Okay? This point, either the highest point or the lowest point, is called the vertex. Parabolas are symmetric, which means that if you draw a line right down the middle where the vertex is, everything to the left and everything to the right of that line is going to be identical. It's like it's looking itself in a mirror. Okay? So plus or minus, if it's a positive A, that means we're going to open up. If we have a negative A, we're going to open down. The absolute value of A is less than 1, which means that is a decimal or a fraction that is smaller than 1. Then the graph is going to widen, or it's going to crush our graph down a little bit. If the absolute value of A is greater than 1, then it's going to make it skinnier, or it's going to stretch our graph. Positive C moves our graph up, and a negative C moves our graph down. Okay? Steps in graphing. We need to find the axis of symmetry. If you remember what I said a little bit ago, the axis of symmetry is an imaginary line that runs vertically straight through your vertex. That is the point where I said everything to the right and everything to the left will be identical, like it's looking itself in the mirror. Okay? To find the axis of symmetry, we're going to use the opposite of B over 2A. Find the x-coordinate of the vertex. X equals the opposite of B over 2A. This is the same as what? This is going to be the same as the axis of symmetry, the AOS. Okay? By using substitution, then we can find the y-coordinate of the vertex. We want to plot the vertex on your graph. We're going to use the x that we find for the x-axis of the x-coordinate of the vertex. We'll take that x, plug it back into the original equation for all of our x's. This will give us our y-coordinate. We need to find two other points to plot and then sketch the final graph. So let's go ahead and do an example. Here's our equation. Y equals 2x squared minus 4x minus 1. So our A value in this case is 2, our B is negative 4, and our C is negative 1. We need to find the axis of symmetry. If you remember, we just went over how to find the axis of symmetry. It is x equals the opposite of B over 2A. So let's go ahead and plug in our numbers in for our letters. So x would equal, the opposite of B would be positive 4. Then we have 2 times our A value, which is also 2. So this would get us 4 over 4, which would be equal to 1. So our axis of symmetry is x equals 1. If you look at our graph down here on the right, if I start at 0, 0, in order to get to the line x equals 1, I will move to the right one place and make a vertical line at that location. This is my axis of symmetry. We want to make that a dashed line because it is imaginary. It's not an actual solid line that is part of our graph. It's just a point that will help us out. Okay. So for the vertex, x value of our vertex, this is how I'm always going to denote vertex. It'll be v colon, and then I use my x coordinate. So the x coordinate of our vertex is our axis of symmetry, so it's 1, comma, now I need to find my y value of my vertex. Okay? In order to do that, what I will do is take my x, which is 1, and plug it back in the original equation. So it's 2 times 1 squared minus 4 times 1 minus 1. So then my y would equal, if I type that through in my calculator using the parentheses in the correct locations, I find out that my y would equal negative 3. So my vertex is actually 1, negative 3. So again, go back to your graph. I go right 1, down 3 from point 0, 0. Let's make a point there. I'll actually use red for that. So if I start at 0, 0, I go right 1, down 3. I end up at my vertex, which is 1, negative 3. Other points on our graph. What we're going to do to figure out the other points on our graph is we're going to make ourselves a table. So we have an XY table. We want to make 5 points. Okay? The point in the middle is my axis of symmetry, or my AOS. Actually, instead of our AOS, what I'm actually going to put as my middle point of this is my vertex. I want to put my vertex in the middle. So my vertex, the x value is 1. It's coming from right here. The y value is negative 3. Okay? Moving to the right, I'm going to add 1. So this would be 2. I'm going to add 1. This will be 3. Moving to my left, on my x values, I'll subtract 1. So 0, subtract 1, and I'll get negative 1. Okay? What I want to do at this point is I'm going to take my x values and plug them back into the original equation. So for x equaling 2, it would be 2 times 2 squared minus 4 times 2 minus 1. If I type that straight through my calculator using the parentheses in the correct locations, what I come up with is that when x is 2, my y is negative 1. Now I'm going to plug 3 back into the original equation. So 2 times 3 squared minus 4 times 3 minus 1. I find out that my y value is 5. Because our parabolas are symmetrical around my vertex, around my axis of symmetry, anything that I have, the value to the right of my vertex is also going to be the same value to the left of my vertex. The value to 2 spots to the right of my vertex will be the same as the value 2 spots to the left of my vertex. Okay? So in order to finish my graph, I'll go to 2, negative 1, and I'll go to 0, negative 1. Then I'll go to 3, 5, and I'll go to negative 1, 5. At this point, what I can do is go ahead and make my U-shaped parabola, and I have made a graph that is symmetrical and a U-shaped, so we have graphed our quadratic function. Let's go ahead and try another example. For each of the following quadratic functions, find the axis of symmetry, the vertex, and 2 other points. Then graph the parabola. So the first step is to find our axis of symmetry. Remember, our axis of symmetry is x equals negative b over 2a. So the opposite of b would be 6 over 2 times 1, because our a value is 1. This would get me 6 over 2. 6 divided by 2 would be 3. So because our axis of symmetry is x equals 3, my vertex is going to be 3, comma. Now I have to use my 3, plug it back in for all of the x's. So I will do that with 3 squared minus 6 times 3 plus 9. This will be what our y equals. Type that straight through in our calculator. We'll come to find out that our y would be 0. So my vertex is going to be 3, comma 0. So if I start at, again, I'm going to use red to graph it. Start at 0, 0. I go right 3, 1, 2, 3. That is my vertex. At the same spot my vertex is, I will have a vertical dashed line, which is my axis of symmetry. Okay? So now we have found our axis of symmetry and our vertex. Now we have to find two other points. So this is where we'll make our table. 1, 2, 3, 4, 5. Remember, in the center is where we're going to put our vertex every single time. So our x value of our vertex is 3, our y value is 0. Add 1 to move to the right, 4. Add 1 to move to the right, 5. Subtract 1 from 3 would be 2. Subtract 1 from 2 would be 1. Now, what I'm going to have to do is I want to put this 4 in for all of my x's to find out what our y value is. So it would be y equals 4 squared minus 6 times 4 plus 9. If I type that straight through my calculator using the parentheses where I should, I end up with 1. Remember, if one spot to the right of our vertex is 1, then one spot to the left of our vertex would also be 1. Now I can put 5 in for all of my x values. If I type that through with the parentheses in the correct locations, I find out that when x is 5, my y is 4. Again, because that's 2 spots to the right of my vertex, 2 spots to the left of my vertex will also be 4, since everything is symmetrical with quadratic graphs. Now to go ahead and graph this, I need to go to 4, 1, and 2, 1. Then I need to go to 5, 4, and 1, 4. At this point, I can connect all my points, try to make it look like a U, and I am done. Okay? On to the next problem. First step is to find our axis of symmetry, which is our x value. So x equals the opposite of b. So negative 6 over 2 times a, which is negative 3. Negative 6 over negative 6 would get me 1. That tells me that the x value for my vertex is 1. I need to find my y value. So I'll take our 1 and plug it back in for all of my x's. So y equals negative 3 times 1 squared plus 6 times 1 plus 5. Type that through in my calculator. I find out that my vertex is at 1, 8. So I go to the right 1 and then I go up to 8. Sorry, I should be using red on that. So there's my vertex. My axis of symmetry is the vertical line that runs through my vertex. Now, remember from the front side, it said if my A is negative, which it is in this case, my graph is actually going to open down. Since my graph is going to open down, it is okay that my vertex is as high as it is on our coordinate plane. Okay. Now that I know what my vertex is, I need to go ahead and make a table to get the rest of my points. Put my vertex in the middle, so 1, 8 goes in the middle. Going to the right, I add 1, so I get 2. Add 1, I get 3. Subtract 1 going to the left, 0. Subtract 1, I get negative 1. Now I need to find out what my y value would be when my x is 2. So y equals negative 3 times 2 squared plus 6 times 2 plus 5. If I type that through, I end up with 5. This should be less than what my vertex was. So that is good that we are less than 8. One spot to the right of my vertex is 5, so one spot to the left of my vertex will be 5. Now I need to put my 3 in for my x value. So negative 3 times 3 squared plus 6 times 3 plus 5. If I type that through, I get negative 4. So again, that should be lower as well, because our graph is opening down. Now to plot our points, I go right 2, up 5, go to 0 and up 5, then I go right 3, down 4, and I need to go left 1, down 4. As I say right 1, left 1, I'm taking that from our point 0, 0, okay? Now from here, what I need to do is go ahead and connect all my points, Try to make it look as much like a U as I can. That looks pretty symmetrical, though I'm not the greatest person when it comes to drawing. All right, on to the last problem. First thing again is to find my axis of symmetry. So x will equal the opposite of b. If you look at this problem, there is something missing. I do not have a b value. Remember, the b value is what is attached to x. The a value is what's attached to the x squared, and the c value is what's by itself. So since there is no b value, my b value would be 0 over 2 times 2. This would be 0 over 4, which would make it 0. So the x value for my vertex is 0, comma, I need to find it, right? So what I'll do is I'll plug 0 in for all the x's. So 2 times 0 squared minus 3. This would get me negative 3. So my vertex, starting at 0, 0, is really just down 3, which means that my y-axis is my axis of symmetry. Now that I know what my vertex is, I need to make my table. The vertex always goes in the middle, so 0, negative 3. I'll add 1 moving to the right, add 1 moving to the right, subtract 1 moving to the left, and subtract 1 moving to the left. Now I need to plug 1 in for all of my x's, so y would equal 2 times 1 squared minus 3. 2 times 1 squared minus 3 would get me negative 1. Then y equals 2 times 2 squared minus 3. 2 times 2 squared minus 3 would get me 5. This should open up because my a value is positive. So let's go from 0, 0. I need to move right 1, down 1. And I also need to move left 1, down 1. Then I need to move right 2, up 5. And left 2, up 5. So it is opening up, which is good. And it is symmetrical around the y-axis. So the most important things to remember here is how to find your axis of symmetry. I do that by taking negative b over 2a. The next step is then to take your axis of symmetry, which is an x value, plug it in for all the x's in your original equation to find the y value of your vertex. I'll use my axis of symmetry as my x value for my vertex, and I will use the y value I just found to be the y value of my vertex. Remember to draw your axis of symmetry on every graph and to plot your vertex. After I've done all that, then I'm going to make a table to find 2 more points on either side of my vertex, and that will allow me to go ahead and graph my quadratic function. If you have any questions over this stuff, please make sure you come in and see me. Otherwise, thank you very much for watching the video, and have a great day.